All right, for our next talk, we have Martin Perez. He's going to talk about some of the pitfalls of benchmarking graphics.
So, hi everyone again. So this time, this is about my day work at Intel, the OSDC. Don't get fooled with my shirt, which is the proprietary version of the Intel driver. So yeah, so I work in the OSDC Finland, and I've been involved in. I mean, the team is involved in performance analysis and improvements in performance. So it's only fitting that I would start working on this. So, pitfalls of benchmarking graphics application, and what can we do about that? Okay, so pretty simple, 3 steps. Introduction, benchmarking, and then suddenly easy bench. We'll see what it means. So the current situation is that we've had more and more benchmarks and games being ported to Linux. And open source drivers have become good enough for users to rely on, and they expect the performance to be stable or increasing. So the problem is that we merge code from people coming from anywhere. Of course, we try to review it, but when you merge code, you always have the risk of breaking the previous functionalities, the rendering, or you could break the performance of one obscure game, or maybe improve the performance for one but regress the others. The other cases are just good. If you improve everything except one thing, it's probably good. Okay, so the review does not catch every kind of issue. So can you see in this patch what the problem is? Because it regressed the performance by 10% in some benchmarks. And it took 13 days to fix it.
Because you're dereferencing a pointer that's not in a hot cache?
No.
Nope.
But you know why.
Oh, because Mazer get format because you're calling Mazer.
Nope.
No, it is stupid.
I know.
Well, of course you know. It's a real-life example.
Yeah, they're missing braces.
Exactly, missing braces. So that the name of the function is color fast clear compatible, and basically because this hunk has been added, then it's always returned false. Oopsie.
Which is why we used to have the coding standard of you always use braces, and then like a couple years ago we changed to, well, the if only has one line, don't always put braces.
And here, it doesn't have always on the line. So
Yeah, well.
Our review should have found that.
Yeah, and just nobody, and that's the thing, is it's easy to overlook that.
So yeah, exactly. So review is difficult, and it was just one part of a longer patch that looked kind of trivial and doing the right thing. So I don't want to shame developers. I think this is I'm personally I'm very bad with this kind of stuff, so I wouldn't shame anyone. And so I just think that it's impossible to predict the performance of a patch. So some factor, it may actually change the alignment of the data or the code, and so suddenly it's going to interact differently with the caches, and you can see a big difference in performance. So Ian has seen that and sent an interesting report. Ian, the problem of changing one function that is not even called, and suddenly performance improved by 3% in CPU limited cases. Oh, why? So data and code alignment is pretty annoying when you're trying to optimize the CPU performance. Then of course the schedulers are not helping. What else? Well, sampler configuration, fair enough. Hardware generation, so you need to have a ton of them to try, and of course there's also the power budgets. For the same generation, you would have maybe a 1.5 watt TDP, then one at 5 and one at 30, one at 65. So they won't react in the same way to a change. So in the end, the only thing that is sensible is to test every platform and every game of interest, which suddenly means, it's out of reach of any developer. So, but that's not it. There's much more than this. So what are the needs for benchmarking? So as a developer, it could be because you're trying to optimize something and you would try to make different experiments, and then you want to compare them, and you need to compare them on not only your machine, but also on multiple machines with different generations and power budgets and OSs and whatever. And for quality assurance, it's also very important to test patch series before they hit mainline. So as we would catch regressions even from contributors that are not from Intel, in my case. It's also important to follow the performance trends, and sometimes managers ask, hey, how well did we do during the past year? And did we improve performance at all? Did it go down? Because QA is usually done with the updated kernel, updated everything, and so you don't really have a retrospective per component. It requires rerunning everything with a fixed system, and the only variable would be the project you're trying to have a look at. So some problems when benchmarking. So it's really easy to screw your results, or try to, you would think that there is a performance improvement or regression that is, I don't know, the order of 3-4%, which is pretty good, but it may just actually be because of the variance that is either inside the run, so you're running the benchmark and it may improve performance at some point and then go down and just oscillate. But there's also the inter-run variance. So you run it once, it can be extremely stable during one run, and you run it again, and suddenly you have up to 10% difference. Why? We're going to talk about that. Another problem is that hardware has become much more complex, especially for power management. It's trying to use as much power as possible until we are thermally limited, or when we reach the power budget for too long. So that's basically the boost feature. But you could also have the GPU just crash, and then the kernel will reset it, but then you cannot really use this performance data because it contained a reset. And this is the kind of stuff that is impossible to do by hand. It's just too annoying, and yeah, no one has the time for that. Another problem is that you need to be able to reproduce results. If you see a performance improvement of, I don't know, 2%, then the next day or 2 months later, you should be able to get the same result again with different components or whatever. And being able to reproduce also means that you need to get rid of all the variance. Oh yeah, this one was lovely. So for instance, I once ran a very long benchmark over the entire weekend, collecting a ton of data, and then I come back and, oh, flatline, no changes at all. I don't believe this. And guess what? I was not using the expected library. I forgot to put the LD library path. So, oopsie, was using the system messer. Yeah, not cool. Yeah, see? Also, so as developers, when you make experiments about performance, usually you're doing it in the same day or in the same week, so it's just, you can remember everything, and you just remember not to update your system. But when you do that over multiple months, and because you want to reproduce stuff, you need to know if you're trying to compare performance results with what was the environment before and after, and did we change anything, and yeah. So what is part of this environment? Of course, the kernel, libdrm, mesa, version, and config. So the config would be how you compiled it, but that's not it. There's also the display server used and the compositor and all that, and the configuration also can change. There's the hardware, of course, that's the obvious one, and the BIOS version. Especially with pre-production hardware, the BIOS changes a ton changes a lot the power management, and you can get very, very big regressions, and it's hard to catch. So let's talk about the variance that you can get between runs or inside a run. So why do we hate variance? Because in absolute, you could just run the benchmark multiple times, and at some point it's gonna go back to 0, the variance. Yeah, the problem is that when a benchmark takes 5 minutes to execute itself, then you cannot really run it 1,000 times. So, okay. So what can we, so yeah, so inside a run, the variance is usually due to power management, but also concurrent tasks. So that would be generating IOs, and so taking logs and generating CPU, GPU load, but also the interrupts from the hardware can screw the result. It's gonna evict the caches, and so yeah, any kind of context switch is bad. And of course, context switch, CPU schedulers and GPU schedulers. As for the inter-run variance, pretty sure it is just due to the memory allocation, not putting the program at the same address every time. And I have seen differences of up to 10% in a very CPU limited case. So like, let's say GLX gears. You run it 2,000 times, and then you have a look at the slowest and the fastest you got, and yeah, 10%. And yeah, that takes an entire night to run, no, actually 2 nights to get to 2,000 points for GLX gears. So it's not really practical. So what can we do to reduce the variance in some cases? I mean, when you're CPU limited, then forcing the CPU to one frequency can be a good thing. Of course, this is only good if you're trying to optimize the graphic driver and not willing to take into account any kind of power management. So you force usually the CPU to a lower frequency than the maximum one, so as you're sure that you won't be thermally limited and not going to throw results away. Then, oh yeah, very important one, pin the game to a single core. This is super important. For some reason, the CPU scheduler sometimes is really stupid with some behaviors, and it would migrate the task 1,000 times per second. And with new processors, every time you would move, each core has a different clock, and they are controlled independently, so it would have to ramp up again. And by the time it's ramped up, oh, well, we're migrating again, because we can. So yeah. So sure. It is definitely a suboptimal behavior. Is it a bug? In some cases, that's what you want.
Yeah, you should be able to figure that out by looking at the things that they ask you to. If you're generating a lot of page calls because you keep, as a consequence of migrating, or you see that you're generating a lot of cache line fills because for a task that you keep migrating between cores, maybe try not doing that for a second. I mean, it's not like you guys don't produce amazingly well instrumented CPUs. Maybe you could like use some of that instrumentation.
Oh, you're not trying. I mean, I'm convinced. Now, yeah.
Also pin the X server.
Yeah, that too. So pin the applications are important.
You were saying then, though, wasn't just things like cache misses and that kind of stuff, but it was actual CPU frequency.
Yeah.
things as well.
Yeah.
And I mean, does the CPU scheduler know about CPU frequency ramping?
Well, it's that's the problem. It's
Tends not.
There's some question of like, depending on the core, you might want lots of cores lit at low frequency as opposed to a few cores lit at high frequency because maybe that gives you a power profile that's different. But I think the performance profile isn't smart enough to pay attention to which core was most recently at the highest C state and try to schedule on that one next. And even if it did, you might end up crashing because now you're forcing more of these to fight for the same cache lines. It's hard. But it is something where you think actually examining the scheduler and trying to characterize the CPU's behavior would be something that
It wasn't a problem before because there was only one clock, and so the slowdown was only done by clock gating. But nowadays, each core has a independent PLL, so that means that, yeah, you need to ramp up every CPU.
one of these days y'all figure out that clock operation is a stupid idea.
And also, Linux is not controlling everything. Some parts are done in a microcode. So, yeah, it's definitely not easy to solve. So if you're trying to benchmark, just get rid of this by pinning your program. That helps.
Yeah, there is some case here that, for example, the performance is good with a single core, but not good for multiple cores.
I agree.
Yeah.
So what he was saying is that it's basically you're skewing the result. It's not anymore the environment that the users are going to run. And if you are trying to use multi-threading to improve the performance, then suddenly you're back to a single core. But yeah, now I'm going to this. Yeah. Oh yeah, an interesting one that helps. Disabling the address space layout randomization and the transparent huge pages, because those are, depending on the addresses, it's just increasing the variance, especially the transparent huge pages, because it's dynamic behavior, and depending on the alignment in the cache, it would, yeah.
Do you have notes at the end of the slides of how to do a bunch of these things, or do we just have to Google for them?
Well, you won't even have to, because my tool is going to do that for you. It's going to be profiles that you can use. And doing the right thing, that's why it's called Easy Bench. Yeah, of course, the logical one. Run as little services as possible. That means less CPU context to switch to, so that means, yeah, less issues. Pin IRQs to another core, again, same principle. You don't want a context switch. So if you pin your game to CPU 2, then you can put IRQs to, I don't know, CPU 3, but not the same one. And of course, properly cool the device. Yeah, okay, so then for the GPU limited cases, same thing, you force the GPU to one frequency, it helps quite a lot. Reduce number of active GPU contexts, so like just running bare X, that helps, no compositor. If you're just trying to check Mesa and not trying to benchmark the display system, then just get rid of it, or as much as possible. And again, properly cool the device. Okay, so as I said, if you change the environment, then the results are not anymore anywhere close to what customers would see. But yeah, you need to be smart. Yeah, that's simple, right? Just be smart. So only get rid of what you're not trying to optimize or track. Anything else, just keep. Yeah. So there's just way too many things to remember, and it's way too easy to screw your results, and doing it by hand is just impossible. So we need to automate as many things as possible. Oh, I've been slow. Okay. So the objective of automating benchmarking is, of course, to avoid or detect human errors. Make sure that the data is valid, and when you try to add data together, do not add data that should not be added to. Be predictable in the execution time. When you run a benchmark, you want to, for instance, during the night, before leaving the office, I would start a benchmark, and I really wanted to finish right before I arrive. So you need to know how long it's going to take. And so, yeah. I'm not going to talk about Easy Bench yet. So also provide as much information as possible. There's nothing more infuriating than running a very long benchmark or set of benchmarks during the weekend, and you just come back and you're like, hey, what is this and why did it behave like that? Oh, I should have this data. Oh, I don't have it. Darn it. So yeah, it's really infuriating. So you should store as much information as you can, but of course it has an overhead, so your call. But yeah, so we need to provide tools to generate this kind of data, and yeah, at least give you a sense of what you should be trying to look closely into. So in concrete goals, what does it mean? So it means that we need to be aware of every library and program that a benchmark is using. How do you do that? So we need to know their version, the SHA one of the version basically that has been used, but for Git development, the compilation flags. We need to be able to get metrics back from the execution, so either through performance counters or CPU usage, the general busyness of the GPU, or just whatever, the power usage. Anything you can have that is not taking too much, adding too much overhead. Store all this information in a report that is, of course, easy to read and to reuse, and understand the performance results and act upon them. Automatically, that means that if we detect something that is wrong, like for instance, performance suddenly dropped in the middle of a run, you run 30 times the same benchmark, and suddenly it started going down and it's stable down. Maybe it's because the hardware is in a state now that is just wrong. So you should not keep on doing that for the entire weekend, and probably just reboot and start again. Or yeah, maybe just get rid of this data, or I mean, it's not getting rid, but yeah, keep it, but show it to the developers when they come back on Monday. It's interesting data, but you should definitely not add this data to the previous data, because it's not what you wanted. It's not clear?
Yeah, I disagree with throwing out data in general. Like, if your workload is causing your CPU to start throttling and you start fast and then you go slow, it's like you can't just throw out the slow ones because that's the system behavior.
It is, yeah, sure. But then you should not try to add data and try to, yeah. Well, it's a complex issue.
Yeah, don't process your data much.
Yeah.
More samples if you're having trouble getting your variance low enough.
If your environment changes, then more samples it's not going to help that much. It's just going to say, okay, in average it was that, and the average is kind of good, but yeah. It's not going to be easy to reproduce. It's going to be impossible, actually. So it's not good data.
Yeah, I think that's a sign that something's just wrong and all of your data is garbage. And you should fix whatever it is.
For the throttling, you're right, but then the GPU reset. If you got a GPU reset just once, then I mean you're not gonna just get rid of all the data that you have and just say no. Just say okay, well this one obviously was an outlier, and so.
Well, then your statistical, but then you don't throw it away, right? Your analysis takes into consideration that there are outliers.
Yeah, and make a report for that. Yeah, but it should.
Reset, I just assume that all data after the GPU run is completely bogus.
Yeah, and if so you need to reboot or something. Well, yeah, but that means manual work.
Right.
No, we cannot do that. So.
You can automatically detect GPU hang.
Yeah, but you need to be able to say, yeah, okay, this data here is not valid anymore, and we need to keep it because it's interesting data, and maybe it will allow you, or you as a developer, to fix the issue. But you should, when you're trying to track performance of something, then if it's just once or twice during the entire weekend, then no, just put the data somewhere else and just, do not use this data. It's bogus. There's no point. Adding data, more and more data to make the average of it is not helping. Yeah, so you need to be a bit smart about this. So that's what I meant by understand performance results and act upon them. It's kind of difficult to make short sentences about this kind of stuff. Okay, so how do we make sure the data is valid? So compute the statistical accuracy and add runs if necessary, so that like using ministat or something. So of course, you need to get information out of the kernel. Every time there is a hardware event that changes the performance, you need to know about it. So GPU reset, or if there is throttling or whatever, you need to know about that. Potentially, just some benchmarks are not going to run because you just regressed so badly that it keeps on resetting the GPU. So there's no point in continuing. So just say, okay, I give up. I'm just going to run this there, And if I have time, I'll just go back and try bisecting it. That's what you need, automatically. So when you have major differences in your, I don't know, patch series or something, you should make sure that anytime you've seen a big performance difference, if it was actually just an issue that, I don't know, difference in configuration, or probably maybe boost just was completely nuts for an hour, could be. So you need to reproduce it later and make sure that this data is actually valid. And if unsure, you could add, you could reboot, but rebooting also takes time, so you should not reboot after every benchmark. It's pretty bad. Collect usage metrics of the resources so as humans can check. That helps, and it make developers, if they don't trust the report, it's going to be useless. So you need to make it trustful. And log all the information in the report. And of course, bisecting performance differences automatically, because it adds more credibility to the report, and also it is a way to reproduce the issue. So, reproducibility. I'm not even sure if this is the way you're supposed to say it in English.
Reproducibility.
Okay. Well, I won't say this word again. So, well, in any case, what you want as QA, so you detect a performance difference and you want to give that information to developers and give all the information that is necessary for them to reproduce the issue so as they can fix it. And reproducing it means as simple as possible. So for instance, if there are some benchmarks that change a bit and some that change a lot, just say, well, you can reproduce that more easily with this one, this benchmark, and that means less variance. And the variance won't have as much as an impact, so it can be reproduced much faster. Okay, now the problem with this is, how do we know what is the current environment of that is used by the benchmarks? Well, it's really difficult, because you cannot use LDD to just get the runtime dependencies, because it's not, it may LD, what was the thing? Is it LD open or something? Well, yeah. So you could, the program just could LD open the system mesa and not use the one from LD library path. And how do you know that? You may not know, so you may think that, hey, this particular benchmark was not affected by any kind of changes, but all the rest changed, so obviously we did it right. Okay, so LDD is not enough. So the only approach that would really work is using strace. Oh wow, it's too slow. So what do? You could run it once with strace and then just assume that it's always the same. Well, it's one way. But what you could also do is just have a look at proc/your PID/maps, and you can have a look at which are the libraries that are currently in use and where they are mapped in memory, but that you don't care. And so if you use this, then okay, it's not too bad. The problem is that at one point do you pull? Is it at the beginning? If you do it too early, then maybe the program won't have had time to LD open. It could be done at the end, but maybe just destructed the context and also got rid of the library. And if you do it in the middle, could work. So you would need to do it at potentially either three different times, and it's a bit annoying, especially when you don't know the execution time.
Are there real cases where you've seen LDD not report the information you need when you have LD library path set? Because
Apparently it has.
benchmark is saying I want to benchmark the 3D stack or building its own.
Yeah, deal open is very common.
Because
I know deal open is really common, but I mean, are they going to specify their own version of the library or one that's not?
So
provided?
they'll,
Give an absolute path, yeah.
So this is very important because, for example, Mesa DL opens all your write markers.
mm-mm.
And for example, if you're benchmarking a game and that game comes in with its own runtime and it's overriding your lib SDC++, in its own runtime, and your Gallium driver is linked against the newer standard lib C++, it will not load, and you'll fall back to SW restring. So it's really important to know which method driver got loaded.
And
so there's
yeah.
lots of examples where DLO will get in your way.
There are benchmarks that wait 5 seconds to read all the textures, and then suddenly they DL open the driver. Yeah. Is it what?
The silver bullet to hook the dynamic linker to log what it's doing.
That means that you.
Literally LD preload. You just need to wrap DLO.
That could be a way.
Yeah. I mean, you then run into the chaining problem with Steam games where like they also
LD
wrap
preload.
DLO open, but nothing API trace hasn't run into already.
And Carl's work on Glaze actually handles all of that correctly. There was a talk at XDC a couple years ago about
What project?
Glaze.
Oh yeah. Well, that's good for GL. Yeah, that's good for GL, and we could definitely use that. That's a good idea. Yeah, Glaze. Okay, yeah, need to remember that. Okay, so when I say no silver bullet, I mean for querying the library version or the version of a program. So we can run glxinfo and just get like, yeah, which Mesa version you're using, but then that's only the one that glxinfo decided to use, and not what the actual benchmark is using. So it's very easy to believe that you're using the right library, but you're not actually using it. Oopsie. Yeah. So the only real solution would be to control the build process and store everything. So for instance, when you compile the .so, then you would store the hash of the file, and then attached to this hash you would have both the configure flags and the version, the Git version, or any kind of data you need to report to developers. Yeah, and you need to do that for everything. So it is difficult. And there are some dependencies that you may not know, because it's not. It could be like using sockets to communicate, like, oh, I don't know, to a compositor. So how do you know that there is this dependency, and how do you get information about the compositor like that? Yeah, so basically getting the environment is difficult, knowing the exact environment. Okay, so what existing tools exist for automating benchmarking? So there is the Forenix testing suite, so PTS that automates the data acquisition, and they have a ton of benchmarks, profiles, so okay. And it also collects some useful metrics, and so the power usage or the temperature. But it is really oriented towards, his readers, the Forenix readers. So it is simple metric. It's just, here is one value, and they are not showing any kind of, all the data is not shown. So you'll understand what I mean later on when I show what kind of report we want. So there's that. So it reads out the environment, but without any guarantee. So basically it is checking, hey, what is the version of the Mesa that is currently installed, and it gets that through glxinfo. And yeah, it's the same with everything. So they are collecting a ton of data, but then they have no guarantee that it actually is what is used by the benchmark. So in most cases this is true, but this is not always. So it hides performance data, and it doesn't really have knowledge about Git and history, and what we need is to be able to bisect stuff automatically. And so it's, yeah, it could not be automated too easily for all our needs. Then Ben Widowski, is this the way I'm supposed to pronounce your name? How do you say it? Widowski. Okay. So he's been making also a tool that is pretty good. So he made very good modeling effort to try to validate the data. So that is really good. And also he detects some hardware events and try to invalidate data if it's not good. So good stuff. But it's great for developers experiment, but for QA it is not, because you need to basically install the graphics stack multiple times in different folders, and then you need to change the LD library path before running a new benchmark run. So manual work, as I said, not good enough. Not anymore.
Chat has scripts to automatically do that.
Say again?
Chat has scripts to automatically set the LD preload variables.
You could, yeah.
Right, I mean, that's just exporting to environment variables. It's not a lot. You can automate that.
Yeah, but it doesn't understand about Git. Yeah, it doesn't know Git. So when you, it's like you have one installed graphics stack, another one, and you compare. Anything after that, it's not possible. You, yeah.
It's a hack, but it works.
Yeah.
So that's false.
Oh, but by Git aware, it doesn't know about the history. That's what I mean. Like it.
Oh, yeah.
Yeah. Yeah. So the version, yeah, I agree. Yeah. So the environment, not too much. I mean, it depends. There's a bit, but it's, yeah, no guarantees. Yeah, you have support for a few. I doubt that. You haven't seen how many we have now. And okay, so it requires manual work. So the reason why I started working in this tool is I had a patch series of 90 patches. So if I had to compile the stack and then install it to a different folder every time, it would be a pain. So yeah, I really wanted to check every commit and see if it was improving or regressing stuff. So yeah, so ideally what we want is a system that manages both the build system, all the commit history and the environment, allow metric collection, and be able to provide a visual report that is useful for developers and that contain all the information that is necessary. And so that's why we started working on EasyBench. So the idea was to provide workflows that would allow automation, and this automation would try to take care of most of the issues that we can. Another idea is that we want to provide a framework, not just a set of, not just one or two workflows, but create like a toolkit that would allow you to tweak everything in the way you want for your particular need, because there's no freaking way we're going to support every use case. And Chris Wilson has been very good at inventing new use cases. So yeah, and we need it to work for both QAs and QA and developer, because a ton of work is needed, and that should be shared. It's just a workflow that is different. So the authors of the EasyBench are myself and Chris Wilson. The license is the MIT. So it got released or open sourced last week, so it's very new, and I haven't made an announcement yet. I'm still trying to work on polishing everything in the way I want, and then I will make it more public. But I have a talk about this. Okay, and the current URL, if you want to have a look at it, is on my private repo on free.stop. So what features do we have? We have a modular architecture, so you can have test profiles. It's just one file in test.d folder, so you can add as many profiles as you want. Oh no, tests, sorry. The profile would be like, hey, I want to test Mesa performance. I want to test the CPU performance of Mesa, and every time you would configure your machine differently. So what we currently do is automate the acquisition of performance data, generate a report that is usable by developers. I'm going to show it to you very soon. We can bisect performance changes automatically, but you still need to ask the developer to, QA to actually run the script. So there is a new version of EasyBench that is coming. Oopsie. Another version of EasyBench that is coming. Oh, come on. Yeah, sure. No Wi-Fi. Done. So, okay. And so, yeah. So we need something that is fully automatic, and when the machine crashes, you need to be able to start again where it was. And so, yeah, I'm making something that is kind of stateless in a way, or at least being able to compare what is the current data that you have and what is the current goal, and just do whatever is necessary to improve towards the goal. And we have Python bindings for almost everything, to acquire data and then also to parse it and generate the reports, so you can do any kind of visualization you want, or if you're just interested in, I don't know, the covariance of this and this and this. It's just parse report, you get a report, and then you get all the commits and all the benchmarks that you run on it, and then you put whatever function you wanna do for generating whatever number, and then print that, and done. So it doesn't take too long. So what we're currently working on is the crash resistant part. So we have a plan, and the code is getting there, but it's not even merged in master yet. It's in a branch. We really want to use the work from Ben, so the modeling approach that would allow us to really understand statistical accuracy, and trying to know if we need more runs, and also use like say, hey, with this much confidence, this is the improvement that you get. So yeah, I really want to spend a lot of time looking at data and making sure that the models we use are valid before I commit to it, because it's so damn good that after that I won't be able to go back and just say no. Okay, and of course detect the environment. To detect the hardware events, actually you have code for that, so you could just take it up. Predict runtimes more accurately. So we already have compilation runtime, execution time figured out. So basically when you compile Mesa or whatever project you're trying to benchmark, it's gonna give you the average compilation time it took. And so it's gonna, after some time, whenever you say, hey, I wanna run this benchmark with all this, as many runs for this, as many runs for that, how long is it going to take? Then you have a pretty good idea of that. Okay, support deadlines and test prioritization. So you could say, I want to get as much data as I can, but it needs to be finished at 9 a.m. on Monday. And deal with it. Just do whatever you want, but you need full utilization of the machine until 9 a.m. And so, yeah, so if some tests are not meaningful, or if you already reached statistical accuracy you wanted, then just do something else and potentially bisect stuff if you can, if you have time. Support sending emails to the authors of performance changes. So that means bisecting, and then suddenly, send an email if there is a performance difference. So that's not to be used by developers, but that's for QA, which would guarantee that only an email would be sent only once and not multiple times. And of course, the email should be public, and so sending it to the right mailing list. And hopefully integrate that with Patchwork, so as whenever you send a patch series on a mailing list, then the performance could be checked at this time. And so it's going to check if it compiles, it's already good. If it applies on master, already good. And then see if there are some performance regressions on the most interesting benchmarks that we have. And then at night, on mainline, you would run more tests. So that's basically, yeah, I guess the plan. I cannot say it's Intel's plan, because, I mean, the general goal, yeah, but not, maybe it's not going to use EasyBench. Well, we are working, and yeah, we'll see. So demo time and questions. Oh, okay. So this is an example of performance report that we have. So first read the big disclaimer. So this came from an unspecified platform with modified clocks, so any kind of value you see is wrong. And you know why. I've been changing a ton of the environment to get rid of the variance, and it is just, do not trust it. Like, I also compile Mesa with different alignments to reduce the CPU variance. So it is really, do not trust any kind of data. And marketing will kill me if, yeah. So yeah, do not read that. So what do we have? So we have this nice Google chart, so you can say, hey, I want to have a look at this particular benchmark, and you can have a look at the evolution and then see, oh my God, what is this? Actually, it is correlated across many. So luckily, I did add some data, and oh my God, the big performance drop comes from this. Okay, oh yeah, of course it doesn't. I won't risk that, but you know what it is? It is what I showed at the beginning. The brace is missing, and the fix is just there. So hopefully I want to automate that, and so you would have in the notes already this information. And it could be even linked here, where you just click and you would see the, yeah, all the information. So yeah, you can also see that, oh my God, here for 2 weeks we couldn't, or maybe a month, we couldn't run this benchmark, and just there too, or this, yeah, there are problems, or performance regression here. Ooh, not good. Hmm? So why didn't we fix this one? So yeah, it is easy to spot. The thing is that it improves other benchmarks. Oh, and yeah. So then, okay, you have a table view, which doesn't really fit because it's, yeah, the resolution is quite bad here. So then you have this. So let's say you are interested in this commit for this benchmark. So you can just click here and you would have, so only run 3 times. So you have the current report, so it's in the blue line, and you would see that it is around 113 FPS. Again, do not read the data. This is just, yeah, what you want to see is trends. That's it. And then you also have the FPS distribution. As this is just 3 samples, it's crap. But if you have 100 of them, then suddenly you can have a look at the shape of the distribution. You can see all the performance data. So for the previous commit of this, for this benchmark, we had this behavior. And this lovely green box here is just giving you a sense of scale of what is 2% of the performance that you get. So as here you're inside and it's super stable inside the 2%. Sometimes it's not as much, like here. Or like here. Yeah. So you can also see the performance inside a run. In this case, it's a bit overkill. So it's the speed of every, how long it took to compile, to execute every frame. So that's why you see so many, yeah, oscillations. And you can see that it's not very consistent. Yeah, so you get this kind of data, and I think this is pretty valuable. And for commits also, you can see like the compilation logs. And oh crap, shouldn't have done that. I don't have the internet anymore. Oh, maybe it worked, maybe not. Yes, it did. Oh my God. Okay, so yeah, so you get this kind of data. It's not as good as what my goal is, but it's already there. And then, I don't know, so do we have, yeah, easy bench. So for instance here, I listed the benchmark that I can run on this machine because that's only what is supported. So GLX gears in full screen or in window, or when it's CPU limited, that means you do not send any kind of batches to the hardware. So of course it's CPU limited. Or run 16 GLX gears at the same time and have a look at that, the performance. Unigine Heaven, again, CPU limited, Valley or not, Sonotic, and I can show you what kind of benchmarks we support. So anything that is Unreal Engine 4, so all the demos you can run, and you can also set the size of the window. So it's, for me, I use it to make it CPU limited by, yeah, putting a very, very small window. Okay, Heaven, Valley. We have GPU test, Lightsmark, CT bench, GL benchmark 27, GLX bench 3 and 3, Lexmark, Poly bench, Finance bench, IGT benchmarks, Cairo demos. Oh, there's not everything. Okay. Some of the tests that come with the GDX, Waxonotic, and yeah, there are a ton missing actually. Oh, sorry. Yeah. So there's also beignet tests. And really, I can't remember how many tests got written. Chris Wilson has been pretty good at adding tests. So yeah. So I think that's it. So do you have any questions? Because oh yeah, I should probably ask for questions now. We have 10 minutes left.
Thank you.